All right, in lesson 10, module 5 here, we're going to be talking about the volume of cylinders. So we were talking before about the volume of right prisms. So we basically focused on rectangular prisms and triangular prisms. And when we talk about volume, we're talking about how much space something takes up. We're talking about how much capacity it has, how much it can hold. Okay, so we're going to continue that train of thought. Okay, but now we're going to be doing it with a cylinder. Okay, so it says a cylindrical stack, we'll see how many times I can say that, cylindrical stack of coins is shown below. The dimensions of an individual coin are shown as well. Okay, so if we look across here, this right here is called its diameter. The distance all the way across a circle is its diameter. Okay, and then it's 1 centimeter high. It says if you need to find the amount of space taken up by a stack of coins, how could you use the dimensions of the individual coin to help? Well, if I could find out how much space this takes up, then I could just multiply it by how many coins there are, because each one is going to take up the same amount of space and the same size. So we'll say that. You could find, and I'm going to say area here. It's really the volume, but because it's timesing by 1, it's not going to change anything. So I'm not going to stress about this, but just if you're wondering, we can find the area of 1 coin and then multiply it by the total height of the stack of coins. Okay, so we found basically the area of this. We just multiply it by how many there are, how tall it is. Okay, so volume. When we talk about area, we talk about it being a two-dimensional thing, length times width, or whatever. That's a rectangle. Base times height divided by 2, that's a triangle, right? So it says the volume is the amount of three-dimensional space. Okay, so now when we talk about volume, we're moving into three-dimensional. Three-dimensional space occupied by an object. Volume can also be referred to as capacity, like I said earlier. What's the capacity? How much can fit in there? How much can it hold? Excuse me. So now let's get into how we find the volume. So it says to find the volume of the cylinder, multiply the area of the base, kind of like we did here because there's only 1, by the height. You got to be careful with the word height, and I'll talk about that in a second. By the height of the cylinder. So if you find the area of the base, multiply by the cylinder. Now notice it says here, this formula can be written as V equals capital BH. Well, doesn't that look familiar, right? That was the same formula that we were using for rectangular prisms and for triangular prisms. So V stands for volume. Okay, in this case, it's volume of the cylinder. Capital B is different than a little b. Capital B stands for area of the base. Area of the base, okay? Capital B, not a little b. It's not like the length is the base, or like in a triangle, we're talking about what is the area of the base. H. Now, one way to describe H is to say height. Yeah, I'm going to do something a little different, okay? Because sometimes we say height, we tend to think it has to be vertical, but it's really not. In this case, height is the distance between the bases. So height in this case could be horizontal, right? It's just how far apart your bases are. Well, think of a cylinder. What is the shape of the base? Well, the base of a cylinder will always be a circle. That's what makes it a cylinder. Okay? If it's a rectangle, it's a rectangular prism. If it's a triangle, it's a triangular prism. If it's a circle, it's a cylinder. So to find the area of the base, we're going to use this formula, and we're going to need to know this one. Pi times our radius squared. So we're going to need to know the difference between radius and diameter. Excuse me. So we talked about it here, how the diameter is all the way across. Radius is going to be halfway across. Okay, so our formula is volume equals base times height. But our area of the base is going to be a circle. So we can write this as volume equals, what is the area of the base? Pi times the radius squared, and then times our h, times our height. So specific to cylinders, volume equals pi times the radius squared times h. Okay, so we're going to use this one now to solve for these. So it says find the volume of each cylinder, use 3.14 per pi. I tend to grab my calculator and use the pi key. So what's our formula? Well, because this has a circular base, it's the same formula, but we can write this as the area of the base is pi times the radius squared times h, distance between the bases. Okay, so now let's plug in the values. Volume is going to equal pi times, now our radius. We talked about how our diameter is all the way across the circle. Notice this one here, it's halfway across, okay? When it's only halfway across, that's our radius. The radius is half the diameter. So in this case, our radius is 6, but our formula says we take it to the second power. And then our height, how far apart are these two circles? And now you can't see the bottom one here, and I didn't do a great job drawing it in, but you can see we want to know how far apart they are. Well, they're 4, so times 4. So that's when you grab a calculator, okay? And I'm just going to type in, actually maybe I can show you here. We'll see how good my calculator is. So I'm going to go pi times 6 squared times 4. And we get 452.3839, we'll say. 450, we'll just round it to the fourth. 452.4. Okay, so I will tell you that if you use 3.14, you get like 0.16 or something. There is a difference. That's a rounding error. Okay, not a big deal. I can still tell if you did it right or not. What do we measure these units in? Well, these were inches, so it's going to be inches, but what type of inches? Volume is measured in, sorry, this is written right on the line there, cubic inches. Because remember, we want to know how many cubes fit into this cylinder. Okay, and it's going to be approximate because as soon as you multiply by pi, you have to approximate it because it's an irrational number that doesn't stop, doesn't terminate, or repeat. Let's look at another example. Our formula, well, we're trying to find the volume of a cylinder, so our formula is volume equals pi times the radius squared times the height. So plug in our values. Volume equals pi times our radius. Now what's our radius? Be careful. Notice 8 here is the length all the way across. We only want the length halfway across from the distance from the center to the outside. Easy to figure out though. If we know the diameter is 8, the radius is half of that, 4. So I'm going to go times 4 squared times height. Now notice this isn't a vertical distance this time, okay? We want to know how far apart the distance between our bases. Well, they're 10, okay? So now if you grab your calculator, pi times 4 squared times 10, we get about 502.7, we'll say. And it doesn't say where to round, so I'm not too concerned. We just want to make sure it kind of makes sense. Okay, don't always just round it to the nearest whole number. Round to maybe the nearest tenth is a good idea. And these again are cubic centimeters. I'm not going to stress about the cubic centimeters, but we really should be labeling these. Okay, let's look at one more example. Okay, our formula. It's a cylinder. Volume equals pi times the radius squared times the height, the distance between the bases. So volume is going to equal pi times our radius. So our radius is the distance, we find our center, okay, and it's a distance from the center to the outside. That was a really poor attempt on my part, so I'll cheat a little bit. Okay, so if the whole thing here from one end to the other of the circle is 10, its radius is half of that. So its radius is 5. So times 5 squared times our height. Again, distance between the two circles. In this case, it's 2.5. So pi times 5 squared times 2.5 is 196 point, I'll say 35 in this case, just so you can see we don't always have to multiply or round to the 10th. So 196.35. Again, now this is feet, and because it's volume, we need approximately 196.35 1 foot by 1 foot cubes to fill this cylinder. Okay, so our formula is the same we were working on before. The difference is because our base is always a circle, the area of the base is going to be pi r squared, and then we just multiply that by the distance between the bases.